Now let me tell you what polymerization is. Okay. See, polymerization is a process in which, say, a large number of simple molecules join together with or without the elimination of simple molecules. Okay. To form a big molecule. Simple. You know, the simple molecules that are joined together are called monomers, right? And the big molecule, whatever is formed, is called polymer. Poly means many, mer means units. So it will have many units of only one kind of species or more than one kind of species. And there is something like with the elimination or without the elimination of simple molecule. See, when it is without the elimination, what we are going to see now, it's called addition polymerization, right? Nothing is eliminated. They simply join together. Now, when you go for something with the elimination, you know, it is called condensation polymerization, wherein simple molecules like water, ammonia are eliminated. So this is overall what polymerization is. A process in which large number of simple molecules join together with or without the elimination of simple molecules. I've given so many points. The simple molecules are called monomers and the big molecule formed is polymer. There are two different types of polymerizations. One is addition, the other one is condensation. Now, in this particular topic, I mean, in this particular chapter, I would actually like to give you example for addition polymerization. The remaining all, of course, will be learning in the topic polymers. See, at very high pressure, and of course at very high temperature, okay, very high pressure, very high temperature, of course a catalyst. Different types of catalysts are employed. You know, in general, in polymerization of ethylene, we use a catalyst called Ziegler-Natta catalyst. Okay, we'll see them all later when we go for polymers topic. Now, let me show you how to make a polymer from monomers. Interesting. Look at this. I'm taking, say, 3 molecules for convenience. Now, consider this thing. This is what we are going to consider finally. You know, during polymerization, what happens is a bond comes here. As and when the bond comes here, even this also comes here. This one goes here. So this is how a polymer is formed, wherein large number of simple molecules join together. Now look at what I'm going to consider. See, I am going to consider this thing, only this. Look at this. It is going to be like, see, this bond, what I have taken now, then CH2, then of course the CH2. Yes, now here you got just one bond. Now this is the bond that I have considered. See, these two are the bonds of this particular molecule, and this, of course, is not the bond of this molecule. I'll give you a problem later, but for now, you consider these things, and then, you know, I can actually write it this way. We can end time. Is that okay? Now, say this is called polyethylene or polythene. You all know what polythene is. We use it most frequently in our daily life. Okay. So this way you can form a polymer. So this is called addition polymer because nothing is being lost during polymerization. Hope this is okay. Next. Now an interesting reaction. See, this reaction is with sulfur monochloride. Okay. Now ethylene reacts with sulfur monochloride. Ethylene reacts with sulfur monochloride. I think I have to actually take two molecules to give an interesting compound. Look at this. Yes. To form this particular compound, called mustard gas. You know, this is alpha, this is beta. For a differentiation, let this be alpha dash and this be beta dash. Okay. Now the name of this compound. It is beta beta dash. Dichloro, right? Dichloro. Now see, it was originally ethyl group. Even this was also an ethyl group, right? But a hydrogen, of course, is replaced by halogen. So let me write it this way. Beta beta dash dichlorodiethyl. Right? See, as such, this is what we call diethyl ether or simply ether. But the difference that we have here is oxygen is being replaced by sulfur. So let me call this beta, beta dash, dichloro, diethyl, thioether. In general, when oxygen is replaced by sulfur, the word thio is prefixed to the name of the original compound. That's what I did. Beta, beta dash, dichloro, diethyl, thioether. Now, this is famously known as mustard gas. You know what mustard oil is? It's called mustard gas. You know it is poisonous. It was used in World War One. Okay. So this is about the reaction with the sulfur monochloride. We are left with one more sulfur. That's it. So let us straight away go for alkadienes. You know, alkadienes are a kind of unsaturated compound. These are the unsaturated compounds with say two double bonds, because this di refers to two unsaturated hydrocarbons having two double bonds. So are called alkadienes. You know, this extra A is added. Whenever we have more than one double bonds or more than one triple bonds, we add this extra A. Of course, we'll get examples now. Now, coming to the general formula of alkadienes, it is the same as alkynes. Right. Now, let me give you the different types of alkadienes that we have. Of course, there are three different types of alkadienes. The first one, isolated dienes. Isolate. See, these are the alkadienes which are separated by more than one single bond. Okay, I mean they've got the double bonds separated by more than one sigma bond. Look at this. See, in this case, n is either greater than or equal to 1. Okay. This is the general formula of isolated dienes. Let me give you a preparation method of these isolated dienes. Consider allyl chloride. So this is allyl chloride. Take 2 molecules of that. Now when this allyl chloride is treated with magnesium in the presence of ether. Now the thing that gets eliminated here is MgCl2, and two such things, two this kind of things add up, get coupled. Look at this. CH2 double bond CH CH2. Anyway, the Cl is last. Another molecule. Yes. Okay, you can actually show it this way. Take these things first. And take another molecule like this. This is what actually happens. Okay, like this. A kind of mirror image. Okay. So this is how isolated alkadiene can be prepared. The name of this particular alkadiene is, see, it has 6 carbon atoms, hexa. Double bonds are after first and after fifth carbon. So it's hexa 1,5-diene, isn't it? Okay. Now see, they are separated by about 3 sigma bonds or 3 single bonds. I told you that the isolated alkadienes are those in which you got 2 double bonds which are separated from one another by more than 1 single bond. Okay. Next. Then the second variety, cumulated dienes. As the name is itself suggests, these are the dienes having double bonds in continuation. Look at this. No separation at all. Continuous. So this is the general formula of cumulated dienes. Let me also give you a preparation method. Okay. Let me consider this. So this is 1, 2, 3 tribromo propane, right? Now this of course can be subjected to dehydrohalogenation using KOH. But a solid KOH is used, and on heating it undergoes dehydrohalogenation. Like you can say in the first step, this H and this bromine are eliminated. So let us eliminate one HBr. Okay, we'll try to show this in a proper way. Look at this. Okay. Now in this case, when we remove this, this will come here. So that is how we get CH2, Br, then C, Br, and a double bond. A simple dehydrohalogenation. Removal of hydrogen and halogen atoms. Now after this, let us use zinc dust in alcohol. We know that it is dehalogenating reagent. It is meant for removing halogen atoms. Come on, let us remove this way. And then this one will come here. So the thing that gets eliminated is minus ZnBr2, right? Then that's it. We got our propadiene, famously known as allene. I have an interesting point for you. Say in allene, hybridization of the central carbon atom is sp, a previous IIT question, because it is involved in the formation of two pi bonds, 1, 1. Whereas these two are of sp2 type, because they are involved in the formation of just one pi bond. So that the preparation of accumulated diene. Let me also give you a property of accumulated diene. A simple one. See, when propadiene is treated with bromine, a simple thing. We know that this bromine gets added across the multiple bonds. Remove a bond, add bromines across the multiple bond. You have added two now, going to add two more. This and then this. Two at a time across the multiple bond. These two, then these two. Now this is what you get. It's called 1, 2, 2, 3. Tetrabromo propane. Right. So this is about the property of accumulated diene. And the next one, which we will be discussing in detail, is a conjugated diene. I mean, it's conjugated dienes